Welcome to the Deep Dive, brought to you by Bluewater Auto Restoration.
Yeah.
This is week 31 of 2025, and just a reminder, we drop new deep dives every Saturday morning. Today, we're doing something pretty cool. We're taking a deep dive into vintage air for 1955 Chevy trucks.
A classic combination. Modern comfort in an iconic truck.
Exactly. So our mission today is really to unpack the whole process of adding a modern AC system, specifically the vintage air one, into these trucks. We want you, the listener, to walk away knowing not just how it's done, but really understanding why certain steps are, well, absolutely critical.
Yeah, it's true. You ever wonder what it really takes to get that modern comfort without, losing the soul of the vintage ride? It's definitely more involved than just bolting parts on. It's like a careful dance, really, between preserving the classic feel and enhancing it, and the details. They really, really matter. For performance, sure, but also for keeping that classic vehicle healthy long term.
Okay, let's dig in then. We're focusing specifically on the 1955 through 1959 Chevy pickups. And the key thing here, as you mentioned, is these are the models without factory air conditioning.
Correct.
Our focus today is the Vintage Air Gen 5 evaporator kit.
That's the one. And when you're looking at these kits, there are basically two main flavors you'll find. You've got the standard controls version and then the deluxe controls.
Okay.
Both kits are pretty comprehensive, though. They both include that core unit, the Gen 5 Magnum module, which has the 444 ECU brain inside. And they come with an accessory kit, too, to get you going.
Right. So before anyone even picks up a wrench, maybe before they even get excited about the cold air,
Yeah.
what's that very first, absolutely crucial step? Something maybe easy to overlook.
Oh, this one's huge. And yeah, easily missed in the excitement. It's simple, but foundational. As soon as that kit lands on your doorstep, before you do anything else, you absolutely must open every single package and meticulously check the contents against the packing list inside.
Okay, why so critical?
Because Vintage Air gives you a 15-day window. 15 days to report anything missing or short. If you miss that window, well, they're not responsible anymore. Imagine getting halfway through
And realizing you're missing a vital bracket or something.
Exactly. Total project stopper. So that initial check avoids massive headaches later. It's step 0.
That's a great practical heads up. So, okay, you've checked your parts, everything's there.
Yeah.
Let's talk foundational knowledge. System requirements, safety stuff.
First up, refrigerant and lubrication. What's the absolute golden rule here?
Non-negotiable. This is critical for the system's health and, frankly, for safety. Vintage air systems are specifically designed, engineered for only R134A refrigerant, period.
Not the old R12, not some newfangled substitute.
Now, don't even think about it. Using anything else, it can cause catastrophic damage. We're talking potential fire hazard ruining the AC system, maybe even damaging the truck itself.
Wow.
And forget about the warranty. Using the wrong stuff voids it instantly. So R134A only. It seems simple, but it's the difference between success and potentially dangerous failure. Got it. Crystal clear. No shortcuts there. And what about the amount? How much R124A are we talking?
Precision matters here. It's 1.8 pounds. That translates to about 28.8 ounces or 816 grams if you're metric. And critically, it has to be charged by weight. You need a proper AC charging station or a good scale.
Why the exact amount?
Because if it's undercharged, it won't cool well. If it's overcharged, it puts a huge strain on the compressor and other parts, and again, won't cool efficiently. It needs that precise balance.
Makes sense. What about oil for the compressor?
Good question. If you get a new Sanon compressor supplied by Vintage Air in the kit, they typically come pre-oiled. But if you're using a different compressor or maybe sourcing one separately, you must check the manufacturer's specs. Some ship dry and need oil added, use the wrong oil or amount, and you kill the compressor fast.
Okay, so get the right stuff in the right amount. How do we protect the system once it's running? Those safety switches you mentioned, like guardians.
Exactly. Guardians is a good word. Think of them as your system's lifeline, its protectors. The kit comes with a binary pressure safety switch. This little guy is crucial. It watches the pressure. If it gets extremely low, which usually means you've lost refrigerant.
Like a leak somewhere.
Right. Or if the pressure gets excessively high, like over 406 psi, it disengages the compressor clutch, shuts it down.
Why? What's the danger?
Well, low pressure means no refrigerant circulating, which also means no lubricant circulating. That'll destroy the compressor. High pressure, that can damage the compressor too, or even blow a hose. Expensive, messy problem. So the switch prevents that catastrophic failure.
Okay, that's the binary switch. I've also heard of a trinary switch. What's the difference there?
Yeah, the trinary switch does everything the binary switch does, protects against too low and too high pressure. But it adds one more function. It sends a signal to turn on your electric cooling fans when the AC pressure hits a certain point, usually around 254 psi.
Ah, so that's essential if you're running electric fans instead of the stock mechanical one.
Absolutely vital. It ensures the fans kick on when the AC needs that extra airflow over the condenser to keep pressures in check. Again, it all comes back to maintaining that proper pressure range for cooling and for circulating that all-important lubricant. These switches are key to the system's survival.
Makes perfect sense. Small parts, huge job. Okay, moving from the inside workings to the physical installation. Anytime you're drilling into the body of a classic, especially through the cowl or firewall, what's a key long-term consideration?
Spot on. Sealing. You absolutely want a watertight seal. For any bolts that pass through the cowl or the firewall, Vintage Air strongly recommends coating the threads with silicone sealant before you install them.
Just helps keep water out.
Exactly. It prevents water intrusion, which can lead to rust, mold, or even electrical gremlins down the line. Protects the truck's integrity over the years.
Good tip. And what about heater hoses? Are they in the kit?
No, heater hoses aren't included. But it's important to know the Vintage Air system uses 58-inch heater connections. If your truck's engine has the bigger 34-inch nipples, you'll need to adapt them. Either use reducers or swap out the nipples for 58-inch ones.
Okay, noted. Now let's shift gears slightly to something often overlooked but absolutely critical when putting modern electronics in a classic, the electrical system. This is where things can get, well, literally whiny, right?
Yes, you're talking about those radio interference capacitors.
Yeah.
On a lot of these older vehicles, those little capacitors might have been removed over the years, maybe during previous repairs. Who knows?
Where should they normally be?
Typically, you'd find one on the positive terminal of the ignition coil. It's got a generator, one on the armature terminal, another on the voltage regulator's battery terminal. Even alternators usually have one built in or attached.
Okay, so they quiet down radio noise. But why does that matter for a modern AC system like this Gen 5? What's the connection beyond just annoying static?
Ugh. It's much more than just radio whine. That whining is a symptom of electrical noise, sure, but those capacitors, they act like tiny electrical shock absorbers. They smooth out the power, and that's crucial for protecting modern computer-controlled stuff like the ECU, the electronic control unit in the Vintage Air system.
From what?
Yeah.
What are they protecting it from?
Voltage spikes. Little bursts of high voltage. They can come from the ignition system firing, the charging system kicking in, even just turning lights on and off sometimes.
So these invisible electrical jolts can actually cause problems for the AC.
Big problems. These spikes are like little electrical punches hitting those sensitive electronics. They can cause the AC unit to unexpectedly reset, behave erratically, act really strange, or worse, they can cause permanent damage to the ECU.
Wow.
Vintage Air builds robust stuff, but there's a limit. If the vehicle's core electrical system isn't clean, isn't stable, the best AC system in the world won't run right. It needs clean power.
That's a huge insight, and it leads right into another electrical fundamental, grounding. Is it really that important? Or just an old mechanic's tale?
Oh, it's gold. Absolutely critical. Think of it as the return highway for all the electricity. You need good, solid, heavy ground straps. From the battery negative post directly to the engine block. That's primary. Then additional solid grounds to the body and to the chassis frame. Make sure those connections are clean and tight.
And specifically for this Gen 5 system.
Yes, the manual makes a big point of this. The blower control ground wire and the main ECU ground wire must be connected directly to the negative battery post. Not just to the chassis nearby, but right back to the battery negative.
Why the direct connection?
It ensures the cleanest possible ground path for those sensitive control circuits, prevents voltage drops, interference, just helps everything behave reliably. Poor grounds are the root of so many electrical headaches and classics.
Okay, message received. Electrical prep is absolutely paramount. Don't skimp there. Now let's get into the actual hands-on stuff. You're standing there, 55 Chevy pickup, tools ready. What's the philosophy for clearing out the old stuff?
Right, you're basically preparing a clean slate. Systematically removing all the original factory heating and, if present, ventilation components. Under the hood, that means disconnecting the battery first, always. Then removing the battery in its tray, radiator core support cover, the original fan and shroud, the radiator itself, maybe a horn on the passenger side, and definitely all the old heater hoses.
Okay, engine bay cleared. What about inside the cab?
Inside, you'll take out the glove box door, keep that, but discard the glove box liner itself. The original control panel and its wires, go keep the wires maybe, but the panel's out. Passenger side vent control goes. You'll need to seal up the kick panel vent opening with silicone. The driver's side vent control gets relocated. And then the big piece under the dash. The entire OEM heater assembly and the defrost ducts, they all come out and get discarded. It's a pretty thorough clear out.
Sounds like it. You mentioned the glove box door. I mean, needs modification.
Yeah, just a small thing but necessary. You have to modify the passenger side glove box door arm and completely remove the driver's side arm. This is just to make sure they don't hit the new, larger evaporator case that's going in. The manual shows how, ensures it all fits nicely. Travel will be a bit restricted, but it clears.
Right. Old stuff out, space cleared. How do we start building the new system back in? What goes first?
You start building the air distribution network, installing the new defrost ducts, the center vent plenum adapter, floor plenum, defrost plenum, using the supplied spring clips and well nuts. Then comes a step that needs real care, installing the evaporator hard lines and critically the O-rings.
Ah, the O-rings. We talked about refrigerant. These seem equally tiny but crucial. Heard horror stories about leaks here. How do you get this right?
You are absolutely right to focus on them. This is where meticulous attention pays off hugely. First, you must lubricate the O-rings. Use the specific refrigerant oil recommended, usually included or specified, not engine oil, not grease, refrigerant oil.
Okay, lubricated, then what?
Then, the seating. This is critical. The O-ring has to sit perfectly on the land or the shoulder inside the fitting. It's designed for a specific groove.
Not just pushed in vaguely.
No. If it's slightly off-center, pinched, or twisted when you tighten the fitting, it will leak. Guaranteed. Maybe not right away, but it will.
And tightening. Just wrench it down.
Definitely not. Each fitting size #6, #8, #10 lines has a specific torque specification, like 1113 foot-pounds for #6, 1520 for #8, 2127 for #10. Too loose, it leaks. Too tight, you crush the O-ring or even damage the fitting, and guess what?
It leaks.
It leaks. Getting this wrong means draining the system, taking things apart again, replacing the O-ring.